Okay, it's on.
YouTube.
I love that. Hi, YouTube. Okay, here we are, 2020, and we're starting a brand new unit. By the way, I've been uploading the blank notes to this too. So if you ever lose your notes, every video in the description there's a link to the blank notes. I've been doing that. So every semester I've just been getting better and better. So let's start with a really basic factoring question. This is from grade 10. Now I'm going to remind you about all sorts of things, but we're factoring trinomials because eventually we're going to be graphing quadratics. Okay, so we have these trinomials. If you were to graph something like this, we don't know it yet, but it's going to look something like that. Or maybe it's going to look like this. Or maybe it's going to look something like that. So we have these x-intercepts. Okay, and we find them by factoring. So we're going to spend basically a large part of a unit just learning a bunch of factoring methods. So that when we get to drawing these in the next unit, we can find the x-intercepts and we can do all this stuff that we need to do. Okay? So I think in grade 10, you guys learned that a trinomial is ax squared plus bx plus c. Does that ring a bell? Okay? And then you learned that, hey, if you just have, if a is equal to 1, then you can factor this and it looks something like x plus a number and x plus another number. Does that ring a bell? Yeah. All right, perfect. And you learned that these two numbers, which are called factors, they have a couple of properties. They multiply to the c term, which is the constant term, but they have to add up to the b term, not big B, little b. There. So if you're looking at this one, we're looking for two numbers that multiply to negative 21. So let's write m for multiply, and have to add to negative 4. I could make the focus a bit better. That's as good as it's gonna get. Yeah. So what did we say?
Negative 7 and positive 3.
Very good. So negative 7 times positive 3 is negative 21. But when you go negative 7 plus 3, you get negative 4. Perfect. And you factor it. And then you guys learned like how to like FOIL them out and all that stuff in grade 10 too. Okay. Now there's a couple different factoring types out there. So just factor each one. We're not going to do every single one, but I will quickly erase and we'll take a look at some of the ones you learned in grade 10. And then I think we reviewed decomposition. You guys learned it in grade 10, right? Yeah, so we'll review decomposition. Again, we won't do all of them. But we will do maybe the first one, because this is, no it's not. So here's some things you should look out for maybe. Always check.
For GCF.
Yes, always check for a greatest common factor before you factor. So look at this one here, we'll just call it A. So if you look at A, well, 3, 6, 24, what do they have in common? 3, perfect. So you can pull out a 3, factor out a 3. So divide this by 3, you get a squared. Divide that by 3, you get negative 2. Divide that by 3, you get negative 8. Now this is a regular factoring question. Because right here, when your a value does not equal 1, and I'm not talking about this a, I'm talking about the a value in your trinomial, right, an ax squared. So if the coefficient of the x squared term is not positive 1, you have to do something called decomposition, which takes a bit of time. Okay, but look, if you realize, hey, I can pull out a 3, now my a value is 1, and you can factor like this. This becomes a regular trinomial that you can factor. Two numbers that multiply to negative 8, add to negative 2, you just have the 3 out in front. So what are those two numbers? So maybe negative 4 and positive 2? Excellent. So that turns a decomp question into a regular factoring question. Let's look at B. Now this one, 3, 7, 4. Yeah. Greatest common factor is 1. So this would be an example of decomposition. So if you don't remember decomposition, let me remind you right now and we'll do B together. You need to get really good at decomp, okay? So decomposition was like this. You're like, oh, first of all, my a term does not equal 1. So if it's not positive 1, it's decomp unless you can pull out a greatest common factor. Decomp had some rules that went like this. You need to find two factors that multiply to a times c. So this times that, so in this case 12, and it still adds up to b. And then our steps were a bit more involved. By the way, even when we do regular factoring, it still multiplies to a times c. But what's the value of a in a regular factoring question? 1. So we just say multiplies to c, but really, I feel like we should say a times c. Anyways, so let's try this one. So I'm going to recopy it for a second. And I like to make a little table, so I just write multiplying to 3 times 4, 12, and it has to add to 7. And you can start with the obvious ones. You can start with 1 and 12, and it's like, well, that's nowhere near 7. You can go 2 and 6, and it's like, almost at 7. And then the other one, 3 and 4. Does 3 and 4 work?
Yeah.
Right, they multiply to 12, and when you go 3 plus 4, you get 7? Yes? Okay. It's called decomp because you're actually rewriting the middle term. So you're going to use these two factors. So you're going to recopy the 3c squared, and then write plus 3c plus 4c. Is that still 7c? 3c and 4c? Yep. Okay, and then recopy the constant term. Do you guys remember if the order you write those in matters? Like what if I did 4c and 3c? It doesn't. You'll still get the right answer, but if you want to make it just slightly easier, try to write the term that has a greatest common factor bigger than 1 first. That matches this. So I wrote 3 and 3 because they're both divisible by 3. Okay? Now, this is the algorithm for decomp. So you find those two numbers, you rewrite the middle term, then you're looking at groups of 2. So you look at these first two numbers. What is the greatest common factor you can pull out? 3c. Okay, so pull out the 3c, divide that by 3c, so you get c plus 1. Perfect. Now look at the last two factors here. What's the greatest common factor you can pull out? 4. So you go plus 4, and then you get c plus 1. Now, if these two binomials are the same, that means you did something right. If they're not the same, you need to go back and see where you went wrong. So your final answer is grab one of those binomials, so the c plus 1, and then the two outside factors form the other binomial, so 3c plus 4, and you factored it. That's decomposition. Okay, it's just a set of steps that works every time to factor. Yes, sir?
It's kind of confusing with the 2 C's in that. Yeah. Is that like there's 2 different C's?
What do you mean?
Well, I mean, right?
You mean like how you get the two binomials that are the same?
No,
or just
the
give all these C's?
3C and 7C.
Yeah.
That's,
Yeah, I know, it really is unfortunate.
yeah, that's mixing up a little bit.
Yeah, yeah. Well, if we used X, would it be better? Or is it just like in general, it's a little confusing? Yes, yes, yes. Decomp is confusing. So you just have to do some practice and make sure that you're okay with it. Yeah. There's really, I wish I had a better answer, but maybe someone on the internet does. I don't know. But yeah, for decomp, you just got to do lots of practice, get good at it. Yeah. Like anything, like, when I first started running, it was hard and, this is the equivalent, right? Instead of confusing, it was brutal, right? Now I run, 6 or 7 miles, no problem. It's just gotta keep practicing till you get there. Yes, sir.
No, I mean like in the 3C, C plus 1, I
Yeah.
can't tell where everything's going.
Oh, yeah. I don't know what I don't know.
Just make one A and one C.
Oh, no, you don't want to just go change the variable.
Yeah.
Yeah, no.
No, that's
I mean, you can. You could say, yeah, but no, we don't want to. Yeah. Okay. All right. I will never use a C again. Yeah. I'm erasing this. Everyone's good. Okay. Another one that comes up frequently is on this list. I mean, this is a perfect square trinomial. It's like, who cares? You can do decomp on it. This is another one where is your greatest common factor?
Yes.
Oh, the things that you thought were C's might have been brackets.
Yeah.
Yeah, sorry, just occurred to me, like, well, that kind of looks like a C.
Oh, yeah,
They were just brackets. Yeah, I'm sorry.
Well, no, I'm really.
I didn't have enough coffee at lunch, I guess. Yeah, those are just brackets. So there's a regular factoring question. This one here, we should review. I call it DOS. Anyone remember what that is? Difference?
Of squares.
Of squares. Another thing you need to remember from grade 10. So, for difference of squares, there's 3 things you need to check. So it's like a little flow chart. If the first one's true, you go on to the second. So the first one is it a binomial? So difference of squares only works for binomials. If the answer is yes, then you ask yourself, Is there a negative sign between the terms, between terms? If the answer is yes, then you check and see, is this a perfect square and is that a perfect square? So, are the terms PS perfect squares? If they are, then a squared minus b squared is what you have, and it factors to a minus b times a plus b, and that's difference of squares. And that pops up kind of frequently. Is that on the screen? Can anybody see? Is that on the screen still over there?
I remember doing it first and I was really bad at this.
Mostly, yeah. Okay, I can't write past the white. That's not on the screen. Okay, so it's like, all right, two terms, yeah. Negative sign, yeah. Perfect square, as in like, can you do the square root of m squared? Get an answer? The answer is yep. Can you do the square root of 16n squared? The answer is yep, you get 4n. Okay, so by the way, this is a and that's b, right? So we say, hey, this is like a squared minus b squared. And if that's the case, it factors to a plus b, so m plus 4n times m minus 4n, so a minus b. There's really no other easy way to factor them, I guess. You just have to recognize. Okay? So that's kind of a recap of grade 10. That's what you should have learned in grade 10. And now if you're sitting there, I remember being in grade 11 pre-calc and kind of being like, oh, it's been like a year. I don't remember. But yeah, you got to go and remember quick, because like tomorrow we're going to be using these. Today actually, but we'll definitely run out of time. Yes, sir.
Do you have like practice questions and sheets that you can give us?
Yeah, if you want, I can give you like a worksheet. I do believe your exercise book has some practice. I would start there. Yeah. You don't need to do a million decomposition questions. Like, you should be able to sit there and be like, okay, what is the algorithm for decomposition? Like, can I tell it to someone else? Can I describe it to someone else? And then go try a couple questions. Yeah, you need to get, fairly fast at it. And of course, it comes up in grade 12, but it's not like the focus of the course or anything. But it's there. Okay. Let's see. Oh yeah, we got 13 minutes. So I'm gonna skip this because we already did this question. Hey, it's that question, but I changed it to X. Isn't this the one we did, but it had C's in it?
Yeah.
So we already did it. Okay. This one, we don't have a lot of time. Like, what this question is it's asking, is this a factor of these polynomials? In grade 12, you learn a way better way. But let's just do one more. The only way for us to know is to actually factor it and see if x plus 3 is a factor. By the way, if something's a factor of a trinomial, what does it mean? Like, it means that x plus 3 does what to that polynomial? Starts with a D. Divides, yeah. So if x plus 3 is a factor, it means that this number goes into this one evenly. Yeah, in grade 12, you'll learn all about the factor theorem and the remainder theorem, but not grade 9, okay? Okay, so why don't we pick one, A or B?
A.
Good choice, let's do B.
Okay.
It just looks like smaller numbers to me. Okay, so it's a decomp because that's not 1 and I can't pull anything out. So look for two numbers that multiply to A times C. 2 times negative 15 is negative 30. Have to add up to, ooh, what's the coefficient if there's nothing there? 1. Very good, man. You guys are smart. Okay, so 1 and 30, no, not close. 2 and 15, no. You know what? When it adds up to 1, the two factors have to be 1 apart. Does that make sense, right? It's the only way. So,
Yeah, what?
if it adds to 1 or negative 1, the two factors have to be 1 apart. For example, the answer is 5 times 6, right? Because if I go negative 5 and then I add 6, I get 1 and I get negative 30. Yes? Okay, now decompose. Well, we're all doing that. Thanks, biology. Okay, so I'm going to write the 6 first because it has a 2 in common with 2. If you don't, you'll still get the right answer, but your work will look different. So there it is. So then I always double check, is this plus this equal to that? Yes it is? Okay, great. So look at the first two terms, what can you pull out? I can pull out between 2 and 6, I can pull out a 2 between x squared and x. An x. Open a bracket, not a c, a bracket. 2x squared divided by 2x is x. 6x divided by 2x is 3. You can double check. This times this should give you that. This times this should give you that. Okay, now I need to look for the last two terms. What can you pull out? They're both they're both negative, so pull a negative 5. Negative 5. This divided by that is x. Negative 15 divided by negative 5 is positive 3. There. If these two brackets match, you've done it right. So then you just grab one of the binomials, and then the two outside factors in the other binomial, and there you go, you factored it.
Wait, can you go slower?
Yeah, like how I get this?
Yeah.
Yeah, so if you did it right, these two brackets match. So you're going to grab one of those, that's one of your factors. And then the two outside factors are the ones that you just put them together in a bracket. So the 2x and the negative 5. And it's just the algorithm, it's just the way it works. Yeah. Now, the question was, is x plus 3 a factor? Yes, it is. There it is. So you can say, yes, it is. There. Questions? Yeah, you can almost try the other one home. You can go on you can go on Wolfram Alpha, right? You guys know about Wolfram Alpha, right? Wolf. I can't. How do you spell Wolfram? Or Wolfram Alpha. If you go to Wolfram Alpha, say factor, type that in. Use this symbol for a square. That is Shift 6 on your keyboard. You can type that in and write factor, and it'll give you an answer. If you're at home and you're like, I don't know how to factor that. Okay? WolframAlpha.com. I don't work for them. I'm not getting. This is not a paid promotion.
You have to say that we only $2 per second. Use the code duplicate.
Okay, now these kind of suck. Yes. Okay, let's do this one. So you'll have like one question on the test. This is stupid. Like I hate this. Like it's just like once you know how to factor some basic stuff. In my mind, I remember in my math degree, like by the time you get to your second or third year, like you're using like computer programs to factor really tricky things because you'll have things that are like this long, and it's like factor that. It's like FML, right? So so it's like in high school we spend all this time like learning how to factor like stuff like this, and it's handy. Like in case you have a decimal. Okay, how do you handle a decimal? Well, multiply by as many tens as you need to get rid of decimals. So it never comes up again, so I kind of hate it, but it's like, I have to show you. If you have decimals, multiply by as many tens as you need. So like in this case, if I multiply everything by 10, then I would get rid of all the decimals, okay? And then you write the factor. I'm going to call it the factor. It's probably a bad word for it. Write the reciprocal. So write the reciprocal of that number in front of the polynomial with brackets. So I'll show you what I mean in a second. Right, because you can't just arbitrarily go change the question. I can't just multiply everything by 10. I just changed it. So you need to undo what you did. So if I multiply this whole thing by 10, right? So every single term gets multiplied by 10. Then I need to write the reciprocal of that to get rid of it in front. So the reciprocal is 1 over 10. So if I write 1 over 10, then I would get 10x squared plus 14x, right? 1.4 times 10, subtract 12. If I were to distribute this back in, I get back to where I started. I didn't change anything. Okay? Questions? Give you a second to catch up. I know we're in a bit of a rush because I want to finish up this topic at least. And then we'll do part 2 tomorrow, I guess. We got like 8 minutes. Okay, now you can factor this using the factoring techniques that we already know. Is there a greatest common factor you can pull out? all divisible by 2. So if I pull out a 2, then I would get 5x squared plus 7x minus 6. What's 2 times 1 over 10? It's 2/10. Reduce it 1/5. Excellent. Now this is just a regular decomposition. Do we have enough time? I don't know. Sure, let's quickly do it. Okay, so you leave that out there. I'm going to go over here and start doing my decomposition. But what are two numbers that multiply to 5 times 6? So negative 30. Let me just do this one. Oh no, adds up to 7. What are my two numbers? And if you're ever stuck, just start with 1 and 30, and then do the next one, 2 and 15. 3 and 10 maybe. Just got to mess with the sign. Negative 3, positive 10. Works. Okay, grab this, put it over here, start decomposing. So you're just going to maintain the bracket. You'll have this 1 out of 5 the whole time you're writing it. So you go 5x squared. What should I write first, the negative 3 or the 10? The 10. So I go plus 10x minus 3x minus 6. Double check. Is that positive 7x? If the answer is yes, keep going. So now you're looking and you're saying, okay, first two factors, I got 1 over 5, and then I can pull out a 5x, and I get x plus 2, right? 5x squared divided by 5x is x, 10 divided by 5 is 2, x divided by x is 1, so that makes sense. And then here, both negatives, so you can pull out a negative 3, and you get x plus 2, there. So now the only difference is you have this 1 out of 5 in front, so you go 1 out of 5 times, grab one of those binomials that are the same, so x plus 2, and then the two outside numbers make up the other binomial, so 5x minus 3, you're done. So you went from this ugly looking thing and you managed to factor it, hooray! Or you could have went to Wolfram Alpha and you could have typed it in, and some smart computer coder did all the work for you one time. Yes? Never, that's what I was just saying. Well,
Like even the normal stuff.
oh, yeah. If you become an engineer, yeah, you'll use it. Yeah. But you're not, like, your average person isn't gonna, like, you know your iPhone is a marvel of technology, right? Like, so much math and engineering and, oh my goodness, like, knowledge of chemistry and physics went into there. Your average person never, is gonna, do that, like, manufacture an iPhone. Yeah, oh yeah, I sure can. Yeah. Yeah, they tend to use this course as a stumbling block, right? Like, you want to be a doctor, well, can you jump this high with your brain? Can your brain jump this high? Yeah. It's just like I don't know, I could talk to you about all sorts of theories and stuff, but yeah. For practicality, most of you will never really do this. Yeah. I told you about the story how I worked with that carpenter. I've worked with almost every tradesperson who's ever come through my door. I usually know them somehow. And I'll be like, can I work with you? So like I know how to do some plumbing, I know like carpentry. I like built apartment buildings with my one buddy in the summer. They would build fourplexes. I would work with them. I learned so many things. But yeah, like the math level of say a carpenter is like you're not factoring stuff. It's not easy. It's not easy being a carpenter, believe me. I was amazed at like the little like tricks my carpenter showed me. I'm like, wow, I'm like, you're so smart. And he's like, ooh, just learned it on the job. Anyways, do you have a question?
Use it in
I'll stop the recording there. We don't have any more time. Bye-bye. See you next time.